You know that feeling,
Yeah.
right? That little bit of dread when a new software update rolls out and suddenly maybe your phone just starts acting weird, or worse, a critical system at work just breaks.
Oh, absolutely. Chaos.
Total chaos. Or maybe the opposite happens. A cool new feature just seamlessly appears, makes your life easier, and you think, wow, how did they manage that without everything grinding to a halt?
That's the million-dollar question, isn't it? And it's really at the heart of what so many IT organizations are trying to master every single day.
So today, we're really going to dig into that. How do organizations deliver IT changes quickly, yes, but also reliably?
Yeah.
Without causing that chaos.
It's a fantastic question. As a professor of information in the Dr. Sampak College of Business, this is something I see students wrestling with, and professionals too, honestly. It's a core challenge.
Mm-hmm.
So for our deep dive today, we're going to unpack two really critical ITIL 4 practices, deployment management and infrastructure and platform management. These are covered brilliantly in Dr. H.Schuessler's book, Mastering ITIL 4 for Information Systems Professionals. Now, they might sound a bit technical on the surface.
Yeah, the names sound a bit dry, maybe.
They can, but trust me, these are absolutely fundamental for business stability and for innovation, too. They're kind of the bridge between having a great idea for a new feature and actually getting it to users safely and smoothly.
Right, connecting the what to the why it matters.
Exactly.
Perfect. So, our mission today, for you listening, is to cut through the jargon, pull out the really key insights, maybe some surprising facts, and how this stuff actually works in the real world using Dr. H.Schuessler's work as our guide.
Think of it as your shortcut to getting genuinely up to speed on how modern IT manages change effectively. Crucial stuff for anyone heading into an information systems career.
Couldn't agree more. Ready to jump in?
Let's do it.
All right, let's start with the first one, deployment management. If you had to boil it down, what's its main job? Its purpose.
Okay, so at its core, deployment management is all about the actual movement of new or changed IT bit software, hardware, whatever, into the live operational environment.
The live environment, okay.
Yeah, where users actually interact with it.
Ah.
The number one goal, minimize disruption, minimize downtime, errors, the bad stuff that happens when things go wrong during a rollout.
So it's kind of the tactical execution arm.
Exactly. It's the bridge, really, between the folks who built and tested the change, like development or release teams, and the IT operations side. It makes sure that change gets introduced in a controlled, coordinated way.
Okay, that helps. Now, one thing that always seems to trip people up a bit, myself included sometimes, is telling deployment management apart from release management. They sound really similar.
They do, and it's a super common point of confusion. It's important to get it straight, though, especially if you're aiming for ITIL certification or just want to work effectively in IT service management. So, think of it like this. Release management is broader. It's about the planning, the coordination, the governance of a whole release package. It figures out what changes go together, ensures they're tested as a unit, and makes that whole package available.
So release management is like planning the party and sending out the invites.
Kind of, yeah. It prepares the package. Deployment management, then, is the team that actually delivers that package. It's the physical or often virtual installation or activation into the live environment.
Ah, okay.
So release management asks, what are we releasing? When's it ready? Deployment management asks, okay, it's ready. How do we get it into production safely right now?
Release preps the package, deployment delivers it. Got it.
That's the essence of it.
And the way these deliveries happen, well, that's changed massively, hasn't it? We're not always talking about those huge weekend-long manual deployments anymore.
Oh, definitely not. The move towards Agile and DevOps has pushed for much more frequent, often smaller, and highly automated deployments. Think continuous deliver, continuous deployment, CI/CD pipelines. And ITIL 4 fully recognizes and embraces this. It makes it clear that even when you're moving super fast, maybe deploying multiple times a day, the need for control and governance doesn't disappear. If anything, it becomes more critical.
So what does that look like in practice, then, for deployment management?
Well, key activities still involve planning the deployment carefully, scheduling it, usually working very closely with Change Enablement to get the right approvals, actually executing the deployment, which might be automated, and then verifying it worked. Critically, there's also early life support, or ELS.
ELS.
Yeah, early life support. It means closely monitoring the change right after it goes live to catch any unexpected issues quickly. But the big theme, whether it's fast or slow deployment, is always reducing risk.
It's amazing when you hear stats, like, big tech companies, Netflix maybe, reportedly deploying thousands of times a day.
Right.
That speed isn't chaos. It's actually the ultimate expression of control, just control achieved through really sophisticated automation and well-defined processes.
Exactly. Safety built into the speed. That's modern deployment management.
Okay, so if deployment management is getting things into the live environment, let's talk about that environment itself. What's covered by infrastructure and platform management?
This is the practice that looks after the underlying foundation. All the organization's tech, infrastructure, and platform resources. We're talking physical servers in a data center, network gear, storage arrays.
The tangible stuff.
Yeah, tangible stuff. But also virtual machines, cloud services like compute instances or databases from AWS, Azure, Google Cloud middleware, container platforms, basically everything that applications and services run on.
So its job is?
Its core purpose is ensuring that whole technology environment is stable, reliable, and performing well. This involves things like capacity planning, making sure you have enough resources, performance monitoring, doing routine maintenance like patching, provisioning new servers or cloud services when needed. It even gets into managing relationships with vendors for hardware or cloud platforms.
Keeping the lights on and the engine tuned.
That's a great way to put it.
Now, when you describe that, it sounds an awful lot like what people might traditionally call IT operations or sysadmins. Is this just ITIL 4 putting a new label on it?
That's a really sharp observation. ITIL 4 definitely reframes a lot of those traditional IT ops functions under this practice, but it's more than just a name change. It explicitly brings modern concepts like virtualization, using hypervisors like VMware or Hyper-V to run multiple operating systems on one physical machine, and the whole spectrum of cloud infrastructure firmly into the picture.
So it's broader, more holistic, maybe?
Exactly. The people doing this work, system administrators, cloud engineers, network engineers, database administrators, they're ensuring those base environments are ready, secure, and optimized for whatever services need to run on them. They lay the groundwork.
So practically speaking, what might a team doing infrastructure and platform management actually do day to day?
Oh, lots of things. They're constantly monitoring the health of servers, networks, cloud resources. They're applying security patches and updates, super critical. They manage the virtualization platforms, maybe Kubernetes clusters for container.
Hey, Kubernetes is huge now.
Huge. They manage the organization's cloud accounts and services, spin up new virtual machines or databases, troubleshoot performance issues, and they're often the first responders when there's an infrastructure-related outage or incident.
So it really is foundational.
Absolutely. It underpins so much. It needs to feed accurate data into Service Configuration Management, your CMDB. It has to work hand in glove with change enablement whenever infrastructure needs modifying. And crucially for our discussion, it has to provide stable, ready environments for deployment management to target.
Okay, that makes sense. So we know what deployment management is and what infrastructure and platform management provides. Let's get back to how those deployments actually happen. You mentioned balancing risk and user impact.
Precisely. The deployment strategy you pick is all about managing that balance. The simplest, perhaps oldest approach is the Big Bang deployment.
Sounds dramatic.
It can be. It means you roll out the new version to everyone, all at once. Simple to coordinate, maybe, but very high risk. If something breaks, everyone is affected, and rolling back can be messy and take time.
Okay, so probably not ideal for critical systems. What's the alternative?
The main alternative is a phased deployment. Here, you release the change in stages or waves. Maybe you start with a small internal group, then one department, then another region, gradually expanding.
Ah, so you limit the initial exposure.
Exactly. It reduces the risk significantly. If you hit a snag with the first group, you can pause, fix it, and the impact is contained. It also lets you build confidence as you go.
That sounds much safer. But what if you need like really close to zero downtime for something super critical like online banking or a major e-commerce site?
Ah, now you're getting into the more sophisticated techniques. That's where things like blue-green deployments really shine.
Blue-green. Tell me more.
Okay, imagine you have two identical production environments. Let's call the current live one blue and a duplicate idle one green.
Identical.
Yeah.
Like hardware configuration, everything.
As identical as possible. You deploy the brand new version of your software onto the green environment while blue keeps handling all the live user traffic.
So green is offline, essentially, but running the new code.
Right. You can then run all your final tests against green smoke tests, integration tests, maybe even let a small internal group use it. Once you're completely confident it's working perfectly,
Then you flip the switch.
exactly, you update your load balancer or maybe make a DNS change, and instantly all incoming traffic gets routed away from blue and starts hitting the green environment. Green becomes the new live environment.
Wow. So the cutover is almost instantaneous.
Pretty much. The beauty is near zero perceived downtime for users. And crucially, if you suddenly detect a major problem on green right after the switch,
You just flip the traffic back to blue.
precisely, blue is still sitting there, untouched, running the old, stable version. It gives you an incredibly fast rollback capability. Major confidence booster.
Okay, I can see that. Thinking about, say, an online store prepping for Black Friday.
Hmm.
They could get the new site totally ready on green, test it like crazy, then flip over instantly. If anything goes wrong with checkout, boom, back to the old version. No lost sales during peak time.
That's the exact kind of scenario where it's invaluable, provides massive business confidence.
But what about that canary deployment you mentioned earlier? How's
Yeah.
that different?
Right, canary deployment. Think canary in a coal mine. The idea is to release the new version to just a tiny subset of your users or servers first. Maybe just 1% of traffic or one server in a cluster.
Like dipping a toe in the water.
Exactly. You then watch that canary very closely. You monitor error rates, performance, maybe even gather direct feedback if it's user-facing. If the canary is happy and healthy,
You gradually send more traffic its way.
yes. You slowly increase the percentage of traffic hitting the new version, maybe going from 1% to 5%, then 10%, 50%, and finally 100%. All the while, you're monitoring. If at any stage you detect problems, you can immediately roll back just by directing traffic away from the new version.
So the blast radius, as you called it, is kept really small initially.
Minimal blast radius. That's the key benefit. It gives you real-world testing feedback without risking a major outage.
Like when a mobile app rolls out a new feature, but only enables it for, say, 1% of users first using a feature flag. If it crashes their app, it's a small group, not everyone.
That's a perfect example of a canary approach in action.
So comparing them, blue-green is like two full environments, instant switch.
Yeah.
Canary is more gradual, maybe doesn't need a full duplicate environment.
That's a good summary. Blue-green often needs double the infrastructure, at least temporarily. Canary can sometimes be done by just upgrading a few servers within the existing environment. And yeah, blue-green is typically an all-or-nothing switch, while canary is incremental. You can even combine them sometimes for complex scenarios.
Fascinating stuff. Now, all this talk about faster, safer deployments, it really leads us to CI/CD, doesn't it?
Right.
Continuous integration, continuous delivery, continuous deployment. These seem foundational to modern DevOps.
Absolutely game-changing practices. They underpin so much of the speed and reliability we're discussing. Let's break them down quickly.
Please do.
Continuous integration, CI, is where developers merge their code changes into a central repository frequently, maybe multiple times a day. Each merge automatically triggers a build and, crucially, automated tests.
Catches problems early, right? Before they get tangled up.
Exactly. Catches integration bugs fast. Then continuous delivery, CD, builds on CI. It means that every code change that passes the automated tests is automatically built, tested further, and prepared so that it could be released to production at any time.
Could be released. So it's ready, but maybe it doesn't go live automatically.
Right. The software is always in a deployable state. The final decision to push it to production might still be manual button press by a release manager or ops team, perhaps after business approval. It's about having the capability to release on demand.
Okay. And continuous deployment.
Continuous deployment takes that one step further. Every change that passes all stages of your automated testing pipeline is automatically deployed directly into production. No human intervention needed for the actual deployment step.
Wow. So if the tests pass, it just goes live.
If it passes, it ships. That requires a high degree of confidence in your automated testing and monitoring.
Okay, so with CI/CD pipelines automating so much, what does that mean for the role of deployment management itself? Does it just disappear?
Not at all, but it definitely evolves. Instead of people manually running deployment scripts or copying files, deployment management under CI/CD becomes much more about defining the standards and building the controls into the automated pipeline.
So designing the process, not executing it manually?
Exactly. They work with developers and operations to define what constitutes a successful deployment, what tests need to pass, what kind of approvals are needed for different types of changes. Maybe standard changes can be pre-approved and automated, while major ones still need manual checks. They ensure the automation adheres to governance, security policies, and best practices. It's about codifying the deployment strategy and managing exceptions.
That makes sense. Shifting the focus upstream, almost. Okay, this is great, but where does all this software actually live? How do organizations manage the underlying infrastructure these days? You mentioned physical, virtual, cloud.
Right. Understanding the different types of infrastructure is key because it affects how you manage it and how you deploy onto it. We can think about four main models.
Okay.
First, physical infrastructure. This is the old school way, right? Tangible hardware servers you can touch, network cables, storage arrays, usually sitting in your own data center or server room.
You have full control, but maybe it's slow to change.
Exactly. Full control, but less flexible. Provisioning new hardware takes time. Scaling up or down is manual and slow. Then you have virtual infrastructure.
Like VMware, Hyper-V.
Yep. Using hypervisor software to run multiple virtual machines, VMs, on a single physical server. This gives you much better hardware utilization, more flexibility. You could spin up a new VM much faster than racking a physical server. It makes creating consistent environments easier and rollbacks potentially quicker, too. It was really the bridge to the cloud for many organizations.
Makes sense. Then the cloud.
Then cloud infrastructure. This is where you consume IT resources as services over the internet from providers like AWS, Azure, Google Cloud. Think infrastructure as a service, IaaS, virtual servers, storage, networking on demand. Platform as a service pays managed databases, application runtimes, even things like container orchestration services like Kubernetes.
So scalability, pay as you go.
Huge benefits. On-demand resources, scalability, pay for what you use, APIs for automation. It enables incredible speed and agility. And finally, you have hybrid infrastructure.
The mix and match approach.
Pretty much. Combining on-premises infrastructure, maybe physical or virtual for legacy systems or sensitive data, with cloud resources for newer applications, bursting capacity, or disaster recovery. The goal is the best of both worlds, but it definitely adds complexity in management.
And I guess we're even seeing things like edge computing now, pushing compute out even further as part of that hybrid mix.
Absolutely. Edge is becoming a really important part of the hybrid landscape for many industries.
So infrastructure and platform management has to deal with all of these.
Yes, the practice applies across all these models. Understanding the characteristics, cost models, and automation capabilities of each is crucial because it directly influences your deployment strategies and tooling choices. Deploying to physical servers is very different from deploying containers to a managed Kubernetes service in the cloud.
Right. So speaking of tooling, for students listening or professionals wanting to skill up, what are some of the key tools and platforms that really make all this automation CI/CD deployment strategies happen? What should they be looking out for?
Great question. There's a vast ecosystem, but some key players really stand out. Jenkins is a classic. It's an open source automation server, incredibly flexible with thousands of plugins. You can use it to build, test, and deploy pretty much anything. A lot of organizations started their CI/CD journey with Jenkins.
Okay, Jenkins. What else?
GitHub Actions is huge now, especially for teams already using GitHub for their code. It integrates CI/CD workflows directly into your repository using simple YAML files. Very convenient, powerful, and becoming increasingly popular.
Integrated right in. Yeah.
Then there's Azure DevOps, particularly its Azure Pipelines component. Is Microsoft's comprehensive platform covering the whole lifecycle planning, code repos, build, test, release, really strong CI/CD capabilities, capable of deploying to Azure, other clouds, or even on-prem.
The full suite.
Yeah, an all-in-one solution for many. And if you're heavily invested in AWS, AWS Code Deploy is their managed service specifically for automating deployments. It handles deployments to EC2 instances, Lambda functions, container services, and supports rolling updates, blue-green canary strategies natively within AWS.
So Jenkins, GitHub Actions, Azure DevOps, AWS Code Deploy, those are big ones.
Definitely key ones to be aware of, but honestly, that's just scratching the surface.
Oh, yeah. What else is critical in this space?
Well, you've got GitLab CI/CD, which is tightly integrated with GitLab's platform. Circle CI is another very popular cloud-based CI/CD service. For more complex enterprise deployment orchestration, tools like Octopus Deploy are common. And we haven't even really talked about the configuration management tools.
Like Ansible, Chef, Puppet.
Exactly. Tools like Ansible, Chef, and Puppet are crucial for automating the configuration of servers once they're provisioned, ensuring they have the right software, settings, security configurations, and then there's container orchestration like Kubernetes, which has its own ecosystem of deployment tools, plus artifact repositories like Nexus or Artifactory to store your built software packages.
Wow, okay. It's a whole landscape of tools working together.
It really is. The main takeaway, especially for students, is that modern, effective deployment management and infrastructure management rely heavily on automation. Learning these tools, or at least the concepts behind them, is essential. They help you speed things up, reduce those risky manual errors, and really live that ITIL principle of optimize and automate.
Optimize and automate. Got it.
Yeah.
Okay, you mentioned configuration management tools, and that makes me think of another term that's everywhere now, infrastructure as code, or IAC. Let's unpack that. It sounds, well, powerful. What exactly is it?
IAC, yeah, it's definitely powerful, and it feels a bit like magic when you first see it work effectively. Essentially, it means managing and provisioning your IT infrastructure, your servers, networks, load balancers, databases, everything through definition files using code.
So instead of clicking buttons in a cloud console or running manual setup scripts.
Exactly. You write code, usually in a declarative language, that describes the desired state of your infrastructure. For example, I need 3 web servers of this type, a load balancer configured like this, and a database with these specs. You check this code into version control, just like application code.
And then a tool reads that code and makes it happen.
Precisely. You use specialized IIC tools that read your definition files and interact with the underlying platform APIs, whether it's AWS, Azure, VMware, to create, update, or delete resources to match your declared state.
Okay, why is this such a big deal? What are the real benefits for IT teams?
Oh, the benefits are huge. First, consistency. Because the infrastructure is defined in code, you can recreate the exact same environment, dev, test, prod, reliably every single time. No more works on my machine issues stemming from environment drift.
That alone sounds amazing.
It is. Second, speed and repeatability. Spinning up a complex environment can go from days or weeks of manual effort to just minutes by running the IAC code. And you can do it over and over. Third, version control. Because it's code, you can use Git or similar tools to track every change, see who changed what, why, and easily roll back to a previous known good configuration if something goes wrong.
History and rollback for infrastructure. Nice.
Changes go through the same code review, automated testing, and approval processes as your application code. And finally, the code itself acts as documentation. It clearly describes what your infrastructure should look like.
So, better, faster, safer infrastructure management. What tools are people using for this? You've mentioned declarative languages.
Yeah, the 2 dominant players you'll hear about most are Terraform and Ansible. Although Ansible is often seen more as configuration management, it can do provisioning too.
Terraform and Ansible. Tell me about them.
Terraform from HashiCorp is probably the leading tool for provisioning infrastructure. It's cloud agnostic, meaning you can use it to manage resources across AWS, Azure, Google Cloud, VMware, and many others using providers. You write declarative code defining your resources, and Terraform figures out how to make the real world match your code.
Okay, so Terraform builds the foundational blocks.
Often, yes. Then Ansible is fantastic for configuring what's running on those blocks. It's primarily a configuration management, application deployment, and orchestration tool. Its agentless typically uses SSH to connect to machines and uses playbooks written in YAML to define tasks, install this package, copy that file, start this service.
So they often work together.
Very often. A common pattern is using Terraform to create the core infrastructure, networks, VMs, databases, and then using Ansible to install software, configure applications, and manage the state of those servers once they're running. Though you can sometimes do configuration with Terraform too, and provisioning with Ansible, they have their sweet spots.
Got it. Can you walk me through a quick example, say, deploying a new web app using ISE?
Sure. Imagine your team needs to deploy a new Python web application. First, someone writes a Terraform configuration. It might define an AWS Virtual Private Cloud, VPC, public and private subnets, security groups to control traffic, an autoscaling group of EC2 instances to run the app, maybe an application load balancer to distribute traffic, and an RDS PostgreSQL database instance.
Okay, all defined in code.
All defined in Terraform files, checked into Git. When it's time to deploy, you run Terraform apply. Terraform talks to AWS and builds all those resources. Maybe it takes 10-15 minutes.
Much faster than clicking around the AWS console.
Way faster and repeatable. Once those EC2 instances, the virtual servers, are up, an Ansible playbook takes over. It connects to each instance, installs Python, installs the necessary libraries using pip, copies the application code from your artifact repository, configures Nginx as a web server, and starts the application service.
Again, all automated from code.
All automated. The entire environment from the network up to the running application is created and configured purely from version-controlled code. Errors are reduced massively, provisioning is fast, and you know exactly what you have. Plus, you can often integrate these tools to automatically update your CMDB as infrastructure changes.
That sounds incredibly efficient. But I assume you still need some governance. You can't just let anyone run Terraform apply on production, right?
Oh, absolutely not. Governance is still crucial. IAC code should go through code reviews, automated testing, using tools like TerraTest or linters, and follow established change management processes for approvals, especially for production environments. Speed is great, but it has to be controlled speed.
Right, aligning with ITIL principles like change enablement. Which actually brings me to the next point. How do deployment management and infrastructure and platform management connect with the other ITIL 4 practices? Because ITIL 4 really emphasizes that everything should work together, doesn't it?
It absolutely does. That holistic view is central to ITIL 4. These practices never operate in a vacuum. The connections are vital.
So where do they link up most strongly? Change enablement seems like an obvious one.
Definitely. Change enablement is probably the most critical link for deployment management. Almost any deployment into a production environment is a change in ITIL terms. It needs to be assessed for risk, scheduled, and authorized appropriately.
So deployment management is essentially executing an authorized change.
Precisely. Change enablement provides the authorization and the context, the why and when, and deployment management handles the how of getting it done safely. In those fast CI/CD environments, this link is often automated. A pipeline might automatically create a standard change record for a low-risk deployment that passed all tests, fulfilling the governance requirement without manual intervention.
Okay, so the process is still followed, just automated. What about release management? We distinguished them earlier, but how do they hand off?
Yeah, the handoff with release management is key. Release management typically builds the complete, tested release package and stores it somewhere secure and definitive, like an artifact repository or what used to be called the Definitive Media Library, DML. Deployment management then picks up that approved package and handles the installation into the target environment. They need to collaborate closely on scheduling, dependencies, and rollback planning. And deployment management often takes the lead on that early life support phase right after deployment, feeding information back for release and service desk teams.
Okay, that makes sense. Now, you mentioned the CMDB earlier, this configuration management database. How does keeping that accurate help during all this activity? It feels like it could easily get out of date with rapid changes.
That's a challenge for sure, but an accurate service configuration management system, or CMDB, is incredibly valuable. When deployment management puts a new application version live, or infrastructure management provisions a new server, the CMDB needs to be updated with those new configuration items, CIs, and their relationships.
Why is that so important?
Well, if something goes wrong later, an incident, having an accurate CMDB helps you quickly see what changed recently, what services depend on a failing component, or who supports it. It aids impact assessment for future changes. If we change this server, what applications will be affected? It's also vital for compliance and audits. And as we mentioned, IAC tools can often automate CMDB updates, helping to keep it synchronized with reality.
So it's the source of truth that supports troubleshooting and planning.
Exactly. A reliable map of your IT landscape.
Are there other key connections we should touch on?
Definitely. Think about incident management. If a deployment goes wrong and causes an outage, incident management processes kick in to restore service, often involving deployment management to roll back or apply a fix. Problem management might then investigate the root cause. Was it a faulty deployment process, inadequate testing, an infrastructure issue? Capacity and performance management works closely with infrastructure and platform management to ensure the underlying systems can actually handle the load of new or changed applications being deployed. You don't want a successful deployment to immediately crash because the servers are undersized. Security management is critical too, ensuring infrastructure is configured securely and deployments don't introduce vulnerabilities. And finally, continual improvement. Both deployment and infrastructure management should be constantly looking at their metrics: deployment frequency, change fail rate, provisioning time, incident counts, to find ways to get better, faster, and safer. It's a continuous cycle.
It really is a whole ecosystem of practices working together. Okay, this has been fantastic for understanding the concepts. Let's try to make it even more concrete with some real-world scenarios. How might these practices play out in different types of organizations?
Great idea. Let's take scenario one, a blue-green deployment at a financial services company. Imagine a large bank needing to update its core online banking platform. Downtime is absolutely unacceptable, and regulations are strict.
High stakes.
It's very high. They decide on a blue-green strategy. Using infrastructure as code, maybe Terraform, they spin up an entirely separate, identical green environment in their data center or cloud. The infrastructure and platform team ensures it mirrors the existing blue production environment perfectly. Release management provides the fully tested new banking application version. Deployment management deploys this version onto the green environment.
Then they test green extensively.
Rigorous testing. Performance tests, security scans, user acceptance testing by internal staff, all while Blue handles live customer traffic. Once everyone signs off, Change Enablement formally approves the switchover during a pre-announced low-traffic maintenance window, maybe late on a Saturday night.
And the switch happens.
The network team or deployment automation flips the load balancer. Traffic instantly flows to green. Deployment management and ops teams monitor intensely during early life support. If any critical issues arise, the plan is to immediately switch traffic back to blue. Assuming all goes well, the CMDB is updated to reflect green as the new production, and eventually, blue is decommissioned or updated to become the next green.
Zero downtime, controlled risk, clear audit trail. Checks all the boxes for a bank.
Exactly. Strong integration of change, release, deployment, and infrastructure management.
Okay, what about a different vibe? Say, a fast-moving tech startup.
All right, scenario 2. Continuous delivery and IAC in a tech startup. This company needs to push out new features for its web app multiple times a week to stay ahead. They live and breathe DevOps.
Speed is everything.
Pretty much, but controlled speed. They have a sophisticated CI/CD pipeline, maybe using GitHub Actions. When a developer merges code, it automatically builds a Docker container image, runs unit and integration tests. Their infrastructure, probably entirely in the cloud, is defined using Terraform, managed via Git.
So how do they deploy? Big bang. Phased.
They likely use a canary deployment strategy. The pipeline pushes the new Docker image to their container orchestration platform, say Kubernetes. It initially configures the platform to send only 1% or 5% of live traffic to pods running the new image.
The canary flies.
Exactly. Automated monitoring immediately checks error rates and latency on the canary instances. If metrics stay healthy for, say, 15 minutes, the pipeline automatically increases the traffic percentage, maybe to 25%, then 50%, then 100%. If metrics degrade at any point, the pipeline automatically rolls back by shifting traffic away from the new version. Change enablement might just involve an automated log entry for these routine, low-risk deployments.
Wow, very automated, very fast, but with safety nets built in.
That's the goal. Rapid feature delivery, enabled by IAC for reproducible environments and CI/CD with automated canary deployments for controlled risk, agility, and reliability.
Okay, one more. What about a big complex enterprise maybe dealing with older systems and newer cloud stuff? A hybrid environment.
Good one. Scenario 3. Infrastructure and platform management in a hybrid cloud enterprise. Think of a large global retailer. They have legacy inventory systems running on-premises, maybe even on a mainframe, but their customer-facing e-commerce site runs on microservices in a public cloud like Azure or AWS.
Complexity alert.
Definitely complex. Their infrastructure and platform management team has a tough job. They need tools and processes to manage both environments. They might use unified monitoring tools that can see into both their data centers and their cloud accounts. They strive to maintain a comprehensive CMDB that accurately maps dependencies between cloud services and on-prem systems.
So what happens when they need to deploy something that crosses that boundary?
Let's say they deploy a new microservice in the cloud that needs to query the on-prem inventory system. The deployment involves spinning up cloud resources via an IAC pipeline, Terraform perhaps, but it also requires network changes, firewall rules adjusted on-prem to allow the cloud service to connect securely, and maybe configuration changes on the mainframe side.
Lots of moving parts, different teams involved.
Exactly. This requires careful coordination. Change enablement plays a huge role in ensuring all parts of the change are planned, assessed, and approved together. The infrastructure team needs deep expertise in both cloud and traditional networking and systems. Deployment management needs to orchestrate the sequence of actions across both environments. Having that single infrastructure and platform management function with visibility across the hybrid landscape is key to preventing misconfigurations or communication breakdowns.
So it's about managing complexity through unified oversight and strong processes.
That's a perfect summary, ensuring they can innovate with cloud services while maintaining stability and control over their entire complex estate.
These examples really bring it to life. What a fascinating deep dive this has been. It's crystal clear now that deployment management and infrastructure and platform management aren't just, back office technical chores. They're absolutely strategic capabilities.
They really are. They're fundamental to how an organization delivers value to its customers and ensures its IT services are stable and reliable. You can't innovate effectively or operate efficiently without getting these practices right.
So for everyone listening, whether you're a student at Tarleton State aiming for a career in information systems or a professional already in the field, what's the key takeaway?
I think the main takeaway is that mastering these concepts truly empowers you. Understanding the nuances, when to use blue-green versus canary, how to leverage the power of infrastructure as code, how to integrate effectively with change enablement and other ITIL practices, these skills allow you to significantly boost the reliability and the agility of IT services. That makes you incredibly valuable.
It really bridges the gap between technology and business outcomes.
Precisely. You become someone who can help the organization move faster, but safer.
Fantastic. So as we wrap up, here's a thought to mull over, building on everything we've discussed today. Take a look at your own organization, or think about the kind of organization you want to work for. How could its deployment and infrastructure practices be improved? Could embracing more automation like IAC, or achieving clearer integration between teams, help them move beyond maybe older, slower approaches and better meet today's demands for both speed and stability?
That's a great question to ponder. Where are the opportunities for improvement in your context based on these ideas?
Definitely something to think about. Where could your IT environment benefit from applying some of these insights?